Hi.
We are 2bNo.1 and our project is the steganography.
Hi, I'm Yilu. I'm in charge of the flatten the image and expand the image.
My name is Minghao and my part is writing the embed function and the recover function.
My name is Anqi. I'm in charge of the app designer.
Okay, then let's begin.
Hi, I'm Yilu. Today I'm introducing the flatten function and the expand function. You see, so the first function is to turn the grayscale image to the black and white image. So I firstly create the 400 by 400 using the zero functions right here, and as using two for loops to illustrate the rows and columns, and this if function is to express that if any point on is larger than 127, the value of the hidden image will be 1. So this part is for the flat image. The next function is the expand function. I'm using this function to turn one layer image to 3-layer image. So firstly, I create a matrix that is 400 by 400 by 3 using zero functions, and I use two for a function to find if any point on the recovered image is equals to 1. So then every point on every layers will be 1. So this process is to turn 1D to 3D. So this is the function of the expand function. So this is part that I wrote about. Thank you.
Hi, I'm Anqi and I'm in charge of the app designer, and this is our small app. As you can see, if you click the load normal image button, you will see the normal image will show in the normal image window, and then you can choose like the image you want to embed it into the image. Maybe I'll choose hidden image 1 or hidden image 2. Either one is okay, so I'll choose hidden image 2, and then we can choose the method we will embed it into the normal image. So now I'll choose method 1, and you can see like this image will hidden into the normal image, and the normal image, like the combined image, will show in the embedded image window. So now we can click this button, and now we can save this image to the file like the app exists, and you can see this is our new image. And after that, we can like recover the hidden image. So we can click load button. We will see like this picture is our new picture, and we can choose the correspondent recovered method. Like in this case, this is method 1, and we can see the hidden image. So this is like the brief introduction to our small app. So what I do just I transfer the code from the MATLAB comment file to the app designer, and to adjust it a little bit, we use the properties, private properties and public properties to plug in our code, and then we add some callback functions. That is like this button. We add callbacks after the private property, and then after when we click the button, we will show the picture. For example, in the app designer, we need to when we call the input and variables, we need to add the app dot instead of just add the input in the code.
In the embedding and the recovering part, we use two different methods that hide and recover the image. And we apply those two methods in all three layers of the dog image so that we can get totally 6 different methods in the app. So let me give you an example of recovering and embedding function of each method. So here is our odd-even function in the red layer. In the code, we use for if to find for any the point of hidden image that value is 0. We can use mode function to check if the same point of dog image is odd, even or odd. If it is even, I will remain it, and if it is odd, I will -1 to make the value of that point become even. For another part, for any point that the value of hidden image is equal to 1, I will make the corresponding points of the dog image odd. And I also use the mode function. When it is odd, I will -1 to make it. When it is even, I will -1 to make it odd. But for here, I write another if function that make embed image equals to 1 when it is 0, so that we can avoid the negative value. So if the image is is odd, I will just remain it. It's the same. And for the recover function, I will input the embed image and create a 400 by 400 matrix of to be the recovery image. And I also use for if loop to make the value of recovery image become 1 when the point of the embed image is odd. Another method is called difference method. In the code, I will use find if to find for any points that the hidden image is equal to 1. I will make a little change to the original dog image. I will -1 for all points that it is not equal to 0, and I will make it become 1 when it is 0, so that I can also for avoiding the negative value. And when the hidden image is 0, I will remain the value of those points the same. In the recover function, first I will create I'll create a 400 by 400 field with ones, and use for and if to get that for any to compare the dog new image with the dog image, and when the dog image any point that dog new image is equal to dog image, I will make the recover image that with that corresponding point become 0, so that I can get black and white. I can recover that image.